So now we continue with image processing and some simple VOI analysis. We'll do that once again using the view tool to understand the tools in their basic form. If we again use the Bruker PCI database, RAT3, then we can select the original dynamic PET whole body, add that and open. So with our dynamic time series, many of the individual frames don't show us a particularly clear anatomy or a broader description of the tracer uptake for a longer time duration. And what we can do is make an average of certain time frames to see that better. Start off by turning on the MIP display using the button in the center of the image display. Select MIP and select an inverse gray color table, and then it's also possible to adjust the threshold so that we see some overview of the activity in this given time frame. As we change the time using the time slider, we see that MIP image change as well until we see the more familiar distribution in the latest time frame. So in this case, what we can see over the duration of the study is that the most prominent tracer uptake is in the brain, in the Harderian glands just behind the eyes next to the brain, in the myocardium, and in the kidneys. So what we can do is use the kidneys as an example for some initial VOI definition and extraction of statistics. So if we explore the time frames, we can find a range where we see somewhat uniform activity in the kidneys. In the initial time frames, we're seeing the injection, and then from frame 7 onwards, we start to see diffuse activity in the kidneys, through to about frame 13 where we start to see these hotspots appearing. So what we could do is average the range 8 to 13 to see the kidneys more clearly, and then use that image for the VOI definition. If you want to see exactly which time frames that means, we can open the image information in the top right of the image display, where we have another button to edit or view the frame times, and then we can see that in fact frame 8 corresponds to about 1 minute into the acquisition, and frame 13 is approaching the 3-minute mark. So that early average reflects an early peak in the activity in the kidneys, which should give us a good contrast. I can cancel this dialog and close the image information. Then if I want to make that average image, I can go to the Tools tab in the top right. The second sub-tab is for averaging of the image, and we have frames selected by default for a dynamic image like this one. We can use the slider on that tab to select frames 8 to 13. Then we'll be running the tool. First we should pay attention to the replace checkbox in the lower left of the Tools tab. If that's active, we will overwrite our data, and at the moment we don't want to do that. So we leave it unchecked and then run the averaging. Once it's complete, we have an average image created, and in our list of images in the top right, we see that new image in the list with the suffix average volumes. In order to see the distribution better, we need to go back to the General Image Manipulations tab, where we can enter an upper threshold of 500 units. Then we can see our distribution in that image, and if we use the MIP as a navigator, we can click in the kidneys and see that high uptake within them. So now we can proceed to the VOIs. We can use the workflow button in the lower right. Transfers us to the next main tab in the tool, where we can start exploring the tools available to us. In this case, we can start with the left kidney. To make things more clear, we can zoom in and we can see the general shape of the kidney highlighted by the MIP. Since we're working with 3D data, it's nicest to start with 3D definition tools. One of the simplest 3D VOIs we can draw is a sphere, but that sphere can then be adapted to the shape of the organ or lesion that we're working on. Now that we have triangulated the center of the kidney, if we click on that spherical object VOI button, then we can choose the radius. We can start with a fairly small sphere of 3 mm radius, and then we can create a new VOI, and we'll see that sphere appear in the kidney. That could already be used for a simple average and exploration of the data. What we can also do then, as long as the VOI adjustment button is activated in the top right of the VOIs panel, is expand and rotate that sphere using the interactive controls in the display. So what I can do is make that sphere more of an ellipsoid, and then we can adjust the position of that by clicking on the small circle icon to the right of the central crosshair. We get a rotation control. Then if I click on the crosshair itself, I can translate the VOI into position. So in this plane, our ellipsoid already fits this kidney uptake relatively well, and in the other planes we can also make some rotation and translation to try and match the activity that we see, and naturally maybe easier or harder than we expect, depending on what we try to do. So that already gives us an initial VOI giving some sort of summary of the uptake in the left kidney. Therefore we can rename that VOI as left kidney, and then perhaps we want to draw a comparable VOI for the right kidney. In that case, without having to zoom out, I can use the MIP as a navigator to take me across to the other kidney. And here we can use a different definition tool for comparison. First of all, I can create a new VOI using the button in the center of the window. Then I can already give it the name right kidney. And as a quick example of another 3D tool, we can select the Hot 3D thresholding tool. In fact, there's a whole sub-menu of tools within this button. For now, we start with the greater than the threshold we click on, Hot 3D tool. And if I click near the edge of the kidney, we can find a location that takes in more pixels that make up that kidney activity. If we're not happy with that, we could clear the contours. Alternatively, we can click again and try to find a definition that includes more of that activity. In general shape, this is reasonable. Later we will see tools where we could smooth this outline and improve it even more. In one of the later exercises, we'll see how we can work on data like this in fusion mode and have more anatomically defined VOIs. Now, for this first exploration of the data, we can already calculate the statistics for these two VOIs that we drew. The statistics button is near the top center of the screen. In fact, again there are many submodes. The default that we work with in version 4.1 is the selected statistics, and for that selected statistics we have a configuration immediately next to that button which allows us to select the statistics that will be calculated. If we calculate everything for every VOI, especially these later statistics mentioned at the bottom, then the calculations could take longer. For now, statistics like average, standard deviation, volume, min and max are interesting. And if we click OK, then we begin the calculations and the statistics dialog will open, allowing us to see our VOIs. In the top right, we can select which statistics we see, perhaps all of them. These statistics can then be copied to the clipboard for transfer into something like Excel, or we can use our own statistics format within PMOD, which has the suffix .voi stat, and if we save those statistics in PMOD format, they can be saved to the database so that they're easily retrievable later on, or they can also be saved out to the file system. In this case, we calculated the statistics for the average image, meaning that we get a single value for that single image volume. If we want to get time activity curves, we don't have to do any recalculation. In fact, because this is an average of our dynamic data, we can simply use the image list in the top right to switch back to the dynamic data. And we see here clearly on the MIP and in the image on the left-hand side that we still have those same VOIs in the same locations describing the kidney. While talking, I'm moving the time frame and adjusting the image threshold. If we move to those earlier time frames where we had more activity in the kidneys, we can see the VOIs in the image. If you want to triangulate those coordinates in the image, we should be careful. At the moment, the 3D tool, or 3D hot selection VOI tool, is still active. I should return to neutral mode. Then I can click in the image and explore the location of those VOIs. Then I could also zoom in. Similarly, we see how the ellipsoid VOI has transferred and the threshold-based 3D detection. Now, if we go back to the statistics calculation, it takes a little longer to calculate because we have more frames included. But then the statistics viewer opens again and shows us not a single value anymore, but the average, in this case, particularly clear if I click on averaged, but the average activity in those VOIs over all the time frames of our study up to our around 60-minute endpoint. Again, these time activity curves can be copied to clipboard, pasted into Excel. We can also save them in our own format. If we will be doing some kinetic modeling, we can even change the mode to time activity curves for the kinetic modeling tool. And we even have a capture mode to be able to capture a quick image of that curve. And as we saw earlier for image capture, then we can paste that quickly into PowerPoint.